So good day. Today we are going to explain about the microprocessor and microcontroller project. So this is our presentation and our team is consists of two-person, which is myself, Edribugin Anawang, and my fellow friend, which is Safisatul Hafifa binti Saudi. Okay, so for our table of content, there is five category, which is the first one is the introduction. We are going to introduce this project. The second one is the project review, which is the flowchart for our project, and it will be explained briefly and it will be explained later. So the third one is simulation. It will be provided the YouTube link for our project to show that our project is working. And for the fourth part, which is our team, we're going to explain about our project and our part in the scope. And for the conclusion, will be conclude all the founding of our project. So that is for the table of content. Okay, so for the introduction part, I'm going to explain briefly about this part, which is for the first one is the multifunctional microcontroller system is a flexible and adaptable embedded system that can execute a variety of jobs and control many operations from a single device. This is meant by it is a fundamental component in a microcontroller unit (MCU), which incorporate a CPU, memory, input and output port, and several peripheral or a single chip. As we know, Proteus is a well-liked piece of software for modeling and creating the electrical circuit. We can create, test, and debug the circuit with the variety of choices in the electronic system in the Proteus. So, as we know, Proteus has a complete range of tools for designing electronic circuit and producing PCB layout are included with Proteus. To develop a whole design, you may design a schematic, arrange the component, and route the traces. Additionally, Proteus has tools for 3D PCB visualization, testing for design rule violation, and producing manufacturing-ready Gerber files. So, as we know, uh, Proteus also enables you to mimic a variety of peripheral device and other components frequently used with the microcontroller, in addition to the microcontroller itself. For example, the LCD screen, sensor, actuator, and communication interface. So we can use the Proteus to develop a lot of a lot of things for the microcontroller itself. Okay, this is our project scope. So the project scope is the main goal of this project is to teach the student to design the electrical circuit with software, which is Proteus. Then they are depending on the specification that are being given in the project instruction. So this is the project description that we find. So for the first one is we design a circuit with a main program and an interrupt mechanism for this project. To execute this project and to simulate it, we utilize a PIC 1F77A microcontroller circuit and the appropriate assembly language. So the microcontroller move to the interrupt service routine in response to signals known as interrupt in order to halt an active program. These interruptions are sent to the microcontroller unit through its internal pins. There are three external pins a hardware interrupt for PIC 18F4550 in INT0, INT1, and INT2. The port B pins are RB0, RB1, and RB2. These interruptions are edge-triggered interruption, meaning that either a rising edge or a falling edge might cause them to occur. As a well-knowledge, microcontrollers are used to execute a sequence of planned program action that result in the necessary output independence and in the output. While your microcontroller is executing another piece of code, there can be emergency situation where another part of your code need immediate attention. This other portion of code can be treated as an interrupt since it need to be attended right away.
Hello, so I will present for the flowchart for the project preview. So first of all, start. Then we declare timeout, RPO, RPI, GIE, RBIE, and RBIF. Then we set delay loop. After that, set interrupt algorithm. Then cell trace B and set at con 1 register to S6. Then in trace B, um, we set RB0 to RB1 as an output and RB2 to RB6 as an input. Then in trace C and trace D, we set as output. Then we set both GIE and RBIE to equal to 1. After that, go to bank cell port B, set port C initial as 07 and set port D RD7 equal to 1. Then set, if it's yes, then um, bit bit test button RB2. Set again, if it yes, then it will go back to bit test button RB2 until it's no. Then it set port C to 20. Then call delay loop. Then it will go back to clear port B, set port B to 0. Then it will end um, the program. Okay, next, when the bit test port B, which is 2, set to no, then it go to bit test RB3, where if it yes, then bit test RB3, go to set again, and if it yes, it go back to set bit test RB3 until it say no. Then we set port C44, call delay, set port C33, call delay, set port C22, and call delay again, and go back to stop. To clear port B, set port B to 0 and end. but but if the set B bit bit test RB2 set to no, then I will go to clear port B, bit set to RB1, then set again. If it's a yes, then bit test to RB, set. If it yes, go back to bit test RB2. Then if it until it say no, then port C equal to 15, call delay, port C equal to 02, call delay, and go back to N. After if the yeah. So next when the bit test RB2 set no, then bit test RB3. Um, if it's no, then it go back um, to N, to clear port B, set port B to 0 and end the program. But if it's yes, then bit test RB3 set. If it yes, it go to bit test RB3 again. Then set again until it say no. Then port C is equal to 43. The call delay, port C equal to 29. Call delay, port C equal to 74. Call delay, then port C equal to 99. Then it will end the program. Before that, it's clear port B, set port B to 0. Then the program will end. So that's all from me. Thank you. So here's the end of the program, where the n is port C99, go up to clear port B and set port B to 0, then end the program.
Okay, for simulation, there will be link given in the YouTube. So please click the link to know the simulation of our project. So for the presentation itself, there is a link will be given in the presentation slide. So this is the part where we meet our team. So our first member, which is Safizatul Hafifa binti Saudi, her job is to make a cover page. This including the slide and the other format. The second thing is to create abstract to to explain the whole of our project. So the third one is the project scope, which is the main whole idea. So the flowchart. So she going to explain about the flowchart and uh, it will be explained briefly. So for the conclusion itself, she going to conclude all the whole subject. So for the simulation, she and I are going to cooperate to design the project. So for the description, it is for something about the project. So about myself, my part is to design the project description also because the project description is a whole, and as we can conclude, it is the crucial part for us to design the whole project. So for the simulation, I also work with her to create the coding and going to provide the simulation in the YouTube video. So for the result itself, I'm going to screenshot the result in the Proteus and provide it in the report. So for the system programming, it is also the provided the code to make the project to be successful. Okay, so for the conclusion, in the end, a multifunction microcontroller system is a versatile and adaptive system that employs a microcontroller to execute a variety of activities or operations. And we can use the Proteus because it offers a virtual environment for developing, testing, and simulating microcontroller-based systems. Prior to actual prototype and production, it enables you to speed the development process, lower the hardware cost, and discover and fix the problem. It is because we can test it on the software without losing anything, rather than we test it on the hardware and we eventually make the hardware become broken. So that's all for our presentation. Thank you.